This is take home quiz number 6, and I'm going to work on this. Please pay attention, uh, click carefully, and if you have any questions, please comment below and I will try to answer. The graph of y, and it's non-calculator, so I'm not using any calculator. The graph of y equal 3x squared minus x cubed has a relative minimum. At what relative minimum means, I'm taking a first derivative, make it equal 0, you get critical points and you make sign chart. Wherever I'm going negative to positive is my relative minimum. So this is the whole process for finding relative minimum, first derivative. In our relative minimum, we always give them as in order pair, like x and y. So we're gonna get the x, which is a critical point. For the y, we're gonna plug it in the original equation. Always do that. So let's take y prime equal 6x minus 3x squared. That's the derivative of this, and I'm gonna make it equal 0. When I make it equal 0, I finish my calculus. If we finish the calculus part, you have several operations that you consider. Only these operations you consider to solve further. Either least common denominator, you do the FOIL, distribute, exponential properties you use, like if same basis multiply, you add exponents, same basis divide, you subtract exponents, and so on. Also we factor. So in factoring, one factor we have when we make factor like this, like a quadratic equation you have, then you factor like that, and another one is a common factor. I always consider first the common factor. So in this case, my common factor is 3x. So I'm gonna go 2 minus x, and I'm going to make it equal 0. So make this portion equal 0, which is 3x equals 0, and make 2 minus x equals 0. So this is going to give me negative x equal negative 2, and this is x equals 0, like divide 3 both sides. So I got this. So one critical point is 0, another one is x equal 2, because you multiply or divide by negative to change the signs. So I'm going to make a sign chart, which is 0 and 2. If I make a sign chart 0 and 2, pick something on this side, probably negative 1 up here, and plug it in the derivative f prime and 3. If I plug in here f negative 1, so if I plug in negative 1 here, it's going to give me negative 6 and minus 3, so it's going to give me positive. No, it's gonna give me negative. I'm sorry, that's not it. Because if I plug in negative 1 here, it's gonna give me negative 6. And then minus, and this is negative, is gonna turn positive. So it's gonna give me negative, yes. Then plug in 1. If I plug in 1, it's gonna give me positive. If I plug in 3, so 6 times 3 is 18. And 3 times 3 9, 9 times 27, that's going to give me negative. So where is my relative minimum? Where it's going negative to positive, which is 0. So 0 is my x. How do I get the y value? You plug in 0 here to get the y value. So it's 0 0, which is A. Question number 2. Question number 2. Pictured above is the graph of f prime x, the derivative of a function f of x. Which of the following graphs could be the graph of f of x? Now f prime x graph means every y value is a slope. You have to write this with it. And they are asking me, if this is f prime, which a, b, c, d graph is the f of x function for it, which means for the f of x, we have to draw tangent slopes. So for this one, we look for the y slopes, y values, like from negative infinity or whatever that number is, negative infinity to negative 2, I have negative y values. And negative 2 to 0, I have all positive y values. And then from 0 to 2, I have positive y values. From 2 to positive infinity, I have negative y values. So And we also know this is upside down parabola, which means it's a negative x squared. I don't know what coefficient goes here. I'm not concerned about it. But I do know it's x squared and it's negative x squared. Now, if this is the derivative f prime x, then what do you think, what is the f of x function was when I took a derivative and it became x squared? Because for the f prime, we know we subtract 1. Like from the exponent, and subtract 1. This is exponent. So I subtract 1 from it. We get 2. So what is the number? I can say this is negative x, but what is the number that I subtract 1 from and get 2? It would be 3. So the original function x cubic. Now this one and that one already cross out. They are linear functions, they are not cubic functions, and we know cubic function, parent function is like this. So either it's b or d. So how are we going to figure it out, b and d? So let's try. This is negative infinity to negative 2, it's negative y values. So this is negative infinity to negative 2. When I draw in, these are f of x functions, so I have to draw tangent lines. So I draw a tangent here, draw a tangent here. These are all negative tangent lines, and this is negative y value, so this one matches. So let's try the other one, negative 2 to 0. This is negative 2 to 0. When I draw tangent lines over here, it's going to give me positive and positive y values. And negative 2 to 0, I do have positive y values, so it's good. Now let's try next one, 0 to 2. So this is 0 to 2 right there. And when I draw tangent lines here, they are positive tangent lines. And they are positive tangent lines, like positive y values here. So that's good. Next one is 2 to positive infinity. And when I draw tangent lines here, I'm going to draw negative tangent lines. And this is negative y values. So it matches. So my answer, technically, I would say it's B. But let's try D and see how the D goes. So I'm going to start with the same color, negative infinity to negative 2, negative y values. So negative infinity to negative 2 right there. I'm drawing tangent lines and they are positive tangent lines. And this is negative y values and this is positive tangent lines. So that doesn't match. So this is not the answer. The answer is B. Question number 3. Let g be twice differentiable function with g prime greater than 0 means the tangent slopes are positive. G double prime less than 0, which means it's concave down for all the numbers x, such that g4 is x, that's the y value, that's x, that's the y value of the following, which is possible value for g6. So they are asking actually a y value. Don't you think if I have y equal mx plus b somehow, then I can plug in the slope, the x, the b, and I will get the y. But since they are asking the first derivative supposed to be positive, so since I don't have any function there, so I have these order pairs. So I'm going to go f of b minus f of a, which means I'm going to go f of b minus a, because the secant slope always close together. The secant means it always comes to the tangent, so it's okay when we do this. So that would be 12 subtract 18, and it's going to be 4 subtract 5, so it's going to give me 6. Negative 6 and negative 1, they cancel out, so positive 6 is my answer. That positive 6 means my g prime is greater than 0, so this is good. Now how do I get the g double prime? If I plug in that slope here, 6x plus b equal y, then I can plug in that 6 over here, that g6 right here, and but I have to have a b. Then I'll get the y, but I have to have a b first. So how do I get b? I pick any order pair. We did these kind of questions in the in 8th grade. 6 times x is 4 plus b. Like I plugged in this order pair. I plugged in that 4 and 12 order pair, and I have to get the b. This is 24, that's 12. Subtract 24 both sides, and I'm going to get b equal negative 12. So my b is negative 12. So now I have to do up here y equals 6x minus 12. Now I have to plug in this 6 for x, and let's see what I'm getting.
So I got 36 subtract 12, which will give me 24. Now y equal 24, but since they said the g double prime supposed to be less than 0, then whatever number is less than 24 in the answer, that will be my answer. So the less than 24 is 21. I can't have 18 because 18 is already a y value. I can't have 15 because 12 in 18 has something in the middle, 15. It has to be something less than 24, which is 21. Question number 4. Determine which of the following statements are true about the function f, f prime, and f double prime. Now, you guys check your memorizing page where it says the connection between all of this. If you check if f prime is 0, then when x equals c, the f double prime is greater than 0. F double prime greater than 0 means it's concave up because double prime deals with the concavity. Is a relative maximum. This is not a relative maximum. It gives me relative minimum. So that's not true. If f prime x is positive, graph f of x is increasing. That's true. And because that was the connection, f of x is increasing, then it means f prime x is greater than 0. That's correct. F of x has a point of inflection, then f prime x has a relative maximum or minimum. If I have relative maximum like concave up is relative minimum, concave down is relative maximum, the point between them is my point of inflection because that's where the concavity is changing. So that's true. So the answer is C.
Number 5, the second derivative of the function is given by f double prime x minus 2 whole square x plus 3. Which of the following conclusions can be made? So what are the conclusions? Concave up, point of inflection, and relative minimum. Or for all of this, we need a second derivative. For concave up, for point of inflection, for relative minimum, we all need first second derivative, you make it equal 0, get the point of inflection, and then make a sign chart to decide if it's concave up or point of inflection, or concave up means if it's positive, point of inflection wherever concavity changes like up and down, down and up. Relative minimum, if it's concave up, then this is relative minimum. So second derivative is already there. I just have to make these equal 0. X minus 2 equals 0 and x plus 3 equals 0. This is going to give me x equal 2, and this is going to give me x equal negative 3, and these are potential point of inflections, like 50%. We don't know yet unless we try the sign chart in the concavity changes. So I'm going to pick something f double prime here, f double prime negative 4, f double prime 0, and f double prime 3. If I plug in negative 4 in here in the second derivative, this is negative 4 minus 2 is going to give me negative 6, and since it's square, it's going to go positive. This one is negative 4 plus 3, so that's negative 1 times negative times positive is negative, so this is all negative. Then I'm going to go 0, and I plug in 0 here and 0 here. This negative 2, since it has a square, it's going to turn positive. So, and this is already positive, so this is positive. Plug in 3. 3 subtract 2 is positive. 3 plus 3 is positive. This is positive. Now, they said f of x is concave up on negative 3 to positive infinity. Negative 3 to positive infinity. So, negative 3 is the only point of inflection here because concavity changes concave down to concave up. So, that's point of inflection. That's true. But for the first one, you should have negative 3 to 2. And then 2 to positive infinity. That's how it's supposed to look like, not negative 3 to infinity, because of that 2 is the x. So that's not true. F prime x has a relative minimum at x equal negative 3. So 2 and 3 is D. Question number 6. If g of x is equal to kx to the power half plus 2x e 2x, for what value of k would a g of x have a horizontal tangent, which means derivative is equal 0? So I have to get the derivative and make it equal 0, and I'm going to plug in that 1 for x, and we will get k. So let's try do the g prime x. If I take a derivative of this, k is a constant, so 2k is like a coefficient, this stays. Half jump to the front, x in negative half subtract 1 is negative half, plus that this 2 stays outside because that's a product rule, f and g. So I'm going to go f is gonna be f prime, which is 1, e
G is going to stay as a G, plus F is going to stay as an F, and G prime means E2x times 2. Take the derivative of the top. Done. Now 2 and 2 cancel out. I'm left with G prime x. I got once K stays on the top, K times 1 is K, and this half is going to go down like a square root, plus distribute that 2e2x plus 2 times 2 is 4x e2x. Now plug in 1 for every x. So if I plug in 1, that's K. If I plug in 1 here, that's 2. If I plug in 1 here, that's e2. Now these are like terms, so 4, 5, 6. This is 6e squared plus k equal g prime 1. Now, since they said horizontal tangent, I'm going to make this equal 0. If I make this equal 0, I'm getting negative 6e squared for the k, and this is A.
4. Now here's the question number 7. The total number of relative maximum. The total number of relative maximum. Like I just need to give them how many relative maximum I have. What is relative maximum? Derivative equals 0, critical points, assigned chart, and positive to negative. So the derivative is already there. This is f prime. So I just have to make it equal 0. I'm going to make x equal 0. I'm going to make x minus 3 equal 0. And I'm going to make x plus 1 equal 0. I just ignore these exponents and square roots and that kind of stuff. And you guys know why I'm doing that. Because if I do x plus 1, I'm just going to show you one more time. X plus 1 to the power 4 equals 0. Then to get rid of the 4, I multiply by 1/4 both sides. Multiply 1/4 and then 1/4. 4 and 4 cancel out. I'm left with x plus 1, and 0 1/4 means 0. So that's the reason we always do that. So this is x minus 1, one critical point. X equal 3, another critical point, and x equals 0. So I'm going to make a sign chart. That's 0, that's negative 1, and that's 3. Plug in f prime negative 2, plug in f prime negative half, plug in f prime 1, plug in f prime 4. So when I plug in f prime negative 2 over here, negative 2, this is negative. And then this is going to give me negative 2 in my, that's negative. And this is going to give me negative 2 plus 1 is negative 1. But to the power 4 is going to give me positive. So negative times negative is positive. Positive times positive is positive. So here we go. That's positive. So let me delete that so we can try another one. Now let's try another one. Plug in negative half. If I plug in negative half, that's negative. Again, this is negative. And if I plug in negative half here, that won't be positive because negative half plus 1 is going to give me positive half. So again, that's positive, everything. Positive. Now let's erase that again. Okay. Plug in 1. If I plug in 1 here, that's positive. If I plug in 1 here, that would be negative. If I plug in 1 here, obviously that's positive. So positive times negative is negative. Negative times positive is negative again. So negative. This is negative. Erase that. Then I'm going to go back and plug in 4. If I plug in 4, that's positive. Plug in 4 here, that's going to give me positive. 4, positive. So everything is positive here. Now, how many relative maximum I have positive to negative? Only 1. You see, 0 is my relative maximum because I'm going positive to negative. This one is not even changing around negative 1, and this one is minimum actually. So maximum is only 1. So the answer is C. Okay. Okay, I have a free response question. In this question, they said the figure above shows the graph of f prime x, the derivative of f of x. The domain is set all real numbers such that -3 to 5. So they said this is f prime, which means f prime x is equal y value. Every y is my slope. So at what values of x does the graph of f have a horizontal tangent? Horizontal tangent means when the derivative is equal 0, right? That's horizontal tangent. So since every y value is my slope and this is f prime, like this is a derivative we are talking about, so that derivative, where the derivative is like every y value is 0, so my y value is 0 here, my y value is 0 here, my y value is 0 here. So this one is gonna give me -2, 1, and 4. So how do I say this? Pick every word from the question. What values of x? We're gonna say at x equal -2, x equal 1, and x equal 4. The graph of this is very easy if you pick the wording from the question. The graph of f of x have horizontal tangent, because f prime is equal 0, because f prime x is equal 0. So you have 2 points for this question, this part of the question. First, you're going to get the point when you identify all of this, like you're going to identify all of that. Okay, identify all of this, it's 1 point, and when you give them reasoning, that's another point. So you have 2 points on this. This is 2 points. Okay, part B. Part B said, let's see. On what open interval is the graph of f increasing or decreasing? Increasing and decreasing means derivative, you're gonna make it equal 0, you're gonna get critical points, and you make sign chart. Since the derivative graph is already given, we know every y value is a slope, so I'm looking for positive y values and I'm looking for negative y values. Simple as that, because increase decrease deals with first derivative, and we make those sign chart and we say, okay, this is increasing and decreasing. But since it's a graph, so every y value is a slope anyway, so I'm gonna say how does it's gonna work. It's gonna go from -3, since there is no arrows, so it means this is like defined point right there, it's not extending, like not infinity. So I'm gonna say -3 to -2 and 4 to 5. These are all my graphs that increasing, and we have to give them like an order pair, kind of, not the order pair, I think we are giving them increasing occur on -3 to -2 intervals. Yes, so I'm gonna say on what they are asking intervals anyway, so just x values on the intervals -3 to -2 and 4 to 5. And then a graph of f of x is increasing, because I'm just going to justify each one of them separately. So because f prime x is greater than 0, then I'm going to say on the intervals, now the interval is the one below x-axis, all the negative y values. So this is all from -2 to 1, because it's touching the x-axis, so I have to separate the intervals, like give them as in separate parentheses, and 1 to 4. So I'm gonna say -2 to 1 and 1 to 4. F of x is decreasing because f prime x is less than 0. Part C said, on what open interval is the graph of x concave up? Concave up and down means second derivative. Make it equal 0, you're going to get point of inflection, you're going to make a sign chart. If it's
positive, then it's concave up. Now, since this is f prime graph, how in the world I can get the second derivative? I'm going to draw tangent lines. So I'm going to draw tangent lines here, in here, in here. These are all negative tangent lines. I'm going to draw tangent lines here. They are all positive tangent lines. Tangent lines here, these are all negative. These are all positive tangent lines. So you can tell where is concave up. Concave up is -1 to 1 and also 3 to 5. So these are concave up. So I'm going to say f of x on what open intervals? On the intervals. What intervals I have concave up? -1, 1 and 3 to 5. The graph of, I'm exactly going the way they are giving me a question, and this is really good. There is chances that you will get like full credit for it. And this is also, I'm writing it, and this is also a practice for the questions that when they say explain in the context of the problem. So I'm just picking everything there. On the open interval, the f of x is concave up because f double prime x is greater than 0. That's a justification. So part C has actually 3 points. You can say these points and then you give them f double prime is greater than 0. Because f prime is greater than 0, and actually also after because, if you guys remember, I said in the class that after because we're gonna say something whatever is given. So if you guys check, the given graph is f prime, not f double prime. So we can keep this f double prime, that's another point, but I have to mention my f prime because f prime x is increasing, because that's how it goes, increasing, and f double prime x is greater than 0. So because we know that when f double prime x greater than 0, then f prime x is increasing and f of x is gonna go concave up. These are the connection. So this is what I have, and again on the memorizing page you will see it. So you get 3 points for this. You're gonna get 1 point for this, you're gonna get 1 point for this, and you're gonna get another point for that. So you have you have 3 points there. Did I say how many points you have for part B? Part B has 2 points. Like